Okay, now comes a very important topic of thesis, that is research data management. So often we see that we collect the data and then we start entering, and then finally when analysis comes, there will be so many mistakes with our master chart that we have to many times do a lot of work to revise, right? So that is why we would like to welcome Dr. Ganesh, who is an associate professor in Department of Cardiology, to take this important topic of research data management. Thank you, sir.
All right. So this is going to be more of a hands-on session. So I want all your attention, and hopefully you have the demo data that we have circulated loaded on your Excel. So just be ready with it. Try to follow along as much as possible, but mainly focus on what we are discussing, because you can go back and always practice. And I think like we are going to focus on the most basic aspects, and I'm going to make it very focused on the commonest errors that we see during when we analyze a master chart. So can I just have a raise of hands? How many of you are doing this as your first project, first thesis, or anything related to data? That's quite a big number. So I think, yeah, so I think I got it right. So we'll go from a very basic level. And next question is, how many of you are actually familiar with Excel to some extent? Raise of hands. Not even half. So okay, those who are familiar, you can feel free to skip the parts which go into very basics of Excel. But the other parts you can are focused on the data management aspect. So today's class will be on managing your research data. Sir, I'll have to switch tabs, so I just kept it open. So today's approach will be to help you build a master chart. So I assume that most of you would not yet have started your master chart. Do you agree? Not started, right? So yeah, so we'll be focusing on how to build a good master chart. So to understand what goes into a good master chart, or what a good master chart is, we'll take a, we'll not go straight away into what are the different aspects or theoretical aspects. We'll start with something else in mind. We'll take an approach that, what Virat Kohli is famous for. You know Virat Kohli? So what is he famous for? What is he famous for? No, not Instagram. Anybody? Not ads. No man. So he is called the chase master, you know that, right? He is known as the chase master. So why is it known as a chase master? Because when you give him a goal, he does really well. And in fact, he is one of the best in the business when it comes to knowing what to do when a goal is given. So we are going to start with that. We are going to try to understand why you are building a master chart, so that you know what it takes to build a good master chart, right? So this is the approach we are going to take today. So first is, what are we using the master chart for? So you have all seen, I think you have all read many articles, and you have seen many fancy tables which come up in the articles, and ultimately in the thesis also you are planning to do something like this, right? You are going to build some tables like this. You have seen these articles? So you are planning to build these tables in your articles, right? So I'll start with the first table, that is summarizing the data. So most of what you need to know about building a good master chart starts with understanding what is summarizing the data. Now, I think many of you would have heard about data types, and a lot of theory classes about what is a numerical data type, what is a categorical data type. Now we will not go into those theoretical aspects, we will just try to understand how they are summarized. Now if you see this, so this is basically a age of the patients which has been summarized here for the entire cohort of 191 patients in one of our published studies. So here we are going to mention that it is mean plus or minus standard deviation. So the entire study, which had 191 measurements of age, has been summarized into just a couple of numbers, that is age, mean and the standard deviation. So numbers you can summarize like this: the mean, that is the average, and a standard deviation which tells you about how much it varies. So this tells you about the central point, and this tells you about how much it varies. And you can see this is about the gender. So gender, there can be only two types, right? Like most often. So there are only two types of gender, so you classify it into male or female. So such data, that is categorical data, we tend to summarize them using percentages. So we tell that we studied 191 patients and 80% of them were men and remaining 20% or so were women. So we're basically counting these categories and then we are summarizing it into a percentage. Now if you come way down, you can see something else also, some other summary data also here. Which is in terms of IQR. What is IQR? IQR is interquartile range. I'll just show you another article for that. So you have these summary tables in almost every study that you will encounter, and you are going to make these when you are going to summarize or write up your thesis. So that comes once you have done your thesis, you have collected your data and then analyzed, and you are starting to write results. That's when you are going to make these tables. So this you can see. Can anybody tell what data this is? So this is urine protein creatinine ratio, which tells us it's 0.75, and then there is something given in the bracket. So this is known as median and interquartile range. This is also another way of summarizing data which is not normally distributed. So we'll not go into the details of what it means. I just want you to know that this is what we ultimately want from the data sheet. So that is the idea that I wanted to give you. So whatever you type into the data sheet ultimately is going to get summarized in one of these ways. Of course, there are certain specialized data types and various specific applications. We are not going to go and cover each and every corner example. Our plan is to cover 90% of the use cases for 90% of you out here. So the remaining we'll handle through, you can come to us, you can talk to your guides and then cover the corner cases, right? So that's how we're going to approach it. We have understood how and what kind of goal you are looking at, and the next step is to understand what are the common errors that you would face in a master chart and how we can best avoid them. So we'll start with the tool we are going to use for data management, and quite simply for most research related to theses or dissertations, Excel is quite a good tool to use, and that should be enough. And what are the alternatives to Excel? There are free alternatives like Google Sheets and LibreOffice Calc that you can use. It's not just Excel, all these have similar functionalities. Now why we are using such a tool like Excel? It's universally available. Most of you have heard it, at least interacted with it once in your school days or somewhere in your MBBS times. It's easy to use, and if you get stuck, it's easy to get help. And most importantly, it's free when you use it. The pro version is free when you use it through your Mahe ID. So there is no need to look for alternatives. You can use Microsoft Excel. But the question is it the ideal tool? If you ask me, like is Excel the best, or is it good enough for all kind of research data management? Simple answer is no. There are big if your data goes into huge numbers into thousands, and if you're collecting doing registries or something, then you would need a more comprehensive tool, something like a SQL database. So we'll again not go into those things, but just for you to understand, there is much bigger world out there in terms of data management, but for your purposes Excel should be more than enough. And try to understand the basics of Excel. That's what we'll be speaking about for the next 5 or 10 minutes. So we are going to start with like really basic stuff about Excel. So I kindly request you to open your Excel Excel demo book, and I want you to go to the file and open a new blank workbook. I hope that's possible for all of you to do. Can I get an S once you have done? You opened a blank Excel book, right? So you can see some familiar aspects. So the basic aspect of Excel that you need to understand is that the entire thing, the file that you save, that you're going to save it as book2.xl or whatever name you give it, this entire thing is called a workbook. And these things at the bottom, you have a plus mark, you can keep adding as many worksheets as you want. So most of the times for thesis data, you'll be having a single worksheet inside a workbook, right? A single final worksheet inside a workbook, and that's going to be your master chart. And the important aspects that you need to understand in Excel for you to enter data effectively and with good quality, is this single small square that you see, this rectangular box that you see highlighted in green is called a single cell, and the name of this cell is given by the address, that is A1. So that will be reflected in the name box. So each of these individual cells, they go on and on and on for almost seemingly ever. Do you have an idea how many cells are there? I mean, let's come to cells later. Do you know how many rows are there in Excel? Has anybody wondered? And how many columns are there? So there are about 1 million rows, roughly 2 to the power of 20, that is more than 1 million rows, and 2 to the power of 14, that is 16,000 columns. So again, like I said, Excel is more than enough for you because none of you are going to use the entire Excel sheet ever. But when you come to data science, you will easily break Excel within no time because data will run into much more bigger sizes than that. So total number of cells will be more than 17 billion cells. So you will not be actually using the entire Excel possibly ever during your thesis life. So this is about the main aspects. So I want you to focus on the formula bar. So whatever you enter here will be reflected here. It's called a formula bar because everything, including formula goes in there. But whatever you type, you can try it out, it will come here. Alright? So it will come here. And then I want you to focus on something known as status bar, which I'll be probably showing you somewhere later. Think this part, this gray area, is known as a status bar. It will show some important information when you're actually working on a Excel sheet. Now I want you to go to the demo data file, and I'll just show you you can go to the demo data and select any of the cell. Like for example, I'm here in C3. You can see that the formula bar reflects the value in it, and then you can see if I select a few cells, what happens. When I select a few cells, you can see the status bar here. It automatically starts showing you the average value and the number of cells that you have selected and the sum, if it has numbers. If it has something else, it will probably just show you the number of cells you have selected because it can't calculate an average or any other metric on that. So this is about the most common aspects of Excel, and you can see things on top here. These are known as tabs, and this ribbon style is familiar to you from I think Microsoft PowerPoint and Word. It's the same kind of interface where you have all the available functionalities made into small buttons available over the ribbon. And a couple of extra points that I want you to know is about what you can do with the cursor. You can see that currently my cursor is like a thick cross, right? When it is like that, you can see it as a selection tool. It will just select all the cells that you want. If you want to enter something, you need to double click there and you can start typing something. Let's say you want to do some copying. What you do is you select a particular cell which you want to copy, and then when you hover to the right bottom corner, it changes into a solid black cross. Now when you do that, it doesn't select anymore. It will start entering the values which was in that cell and it gets copied there, and you have several options here which you can use. So once you drag it, you have several options that are available already to you, which can be like filling the series. Like if you want to fill serial numbers into something, you would go and select series, it will automatically fill the series into it. Like these are all the basic aspects of Excel, and other cursor aspects are how to select a column. That is, if you hover over the column, you can see it becoming a thick black arrow. When you select that, it selects the entire column, and then when you hover over the row, it becomes again a thick black arrow, which will help you select the entire row. And the last aspect would be the formula part. So Excel supports all kind of functions that you would need to calculate certain variables built into it. Like any formula in Excel starts with equals. The moment you write equals in Excel, it understands that it is a formula. So the moment you write equals, like let's say you want to sum something, you just type the sum and then you open a bracket, and then whichever cells you want to sum, you just select them using the cursor trick that I told you, and then you just press enter and it sums it up, and then you drag it down, it applies the formula, corresponding formula in each of the cells. Like you can see that I summed up only A1 and B1, you can see the formula here, but when I dragged it, it has automatically named it A3, B3 or A5, B5 according to relative notions. So Excel can do all these small things for you, and actually Excel is quite versatile, and these are, it's like very basic stuff that we want you to know. But if you want the other end, what exactly, like what more can you build with Excel, you can see that people have built several games also with it. Like that's quite versatile. It's actually even considered as a programming language in itself. I think you have seen this game, Angry Birds. It's been built by somebody in Excel itself. And you can see this famous mobile game 2048, again built on Excel with a nice graphical user interface also. And there are several games, Monopoly and Snake, and a lot of games have been, even I saw one person building a tennis game which you play with keyboard also inside Excel. So it's quite a versatile tool, and it's worth investing some time learning Excel, especially when you're doing, for anything, not only just research data management, for anything. And once you know Excel, it's the same across Google Sheets or LibreOffice Calc. It's all same spreadsheet software only. So I hope I've given you a basic introduction about Excel and you're comfortable. Any doubts still here? You're able to follow most of it? Yeah. So next, from here I would want you to focus properly, because there are some key aspects that you learn here. So I want you to understand the difference between what is an Excel table. Again, this terminology applies to Excel alone, not for the other software. What is an Excel table and what is an Excel spreadsheet? Now, so far what we have been working, these blank workbooks, these are all sheets that I already told you. These are all worksheets, or known as spreadsheets. You can enter values anywhere, it will not complain whatever value you enter. So it doesn't matter, if you enter it, it just knows that, okay, there is some entry there, that's it. So this is known as a worksheet. But when it comes to thesis research, we want certain rules to be followed. So I'd recommend that you use some feature in Excel known as Excel table. Now, to make you understand, I'll take a couple of minutes and try to make you understand how important it is to use tables instead of a spreadsheet. Now, I want you to open this sheet below in your demo file, known as the spreadsheet. So there are a lot of sheets I made here for demonstration here. I want you to go to the spreadsheet one. So I've color coded it for your understanding. Actually, when you enter it, it will all be blank or plain, as you saw already. But I've color coded it for your understanding to demonstrate some important differences. Now you can see that this looks like a preliminary entry of some particular thesis, right? A part of the thesis data which has been entered here. Now you can see that the first row is all variable names, and then other rows are all entries related to some of the patients in the study. So this is how we typically start entering data into an Excel file. So what you see here is single row is that of a single patient data. So this is the number given to him. We don't usually write patient names or identifying details here. So we usually give a study number, and then that is one particular patient. So I've colored it in green, which means that this SRC1 patient, the entire row is his or her data. So in this case, it's his data, right? So I've marked it in different colors to demonstrate something very important. Now this is something which has happened in reality. I'll just show you with one of our PhD students. So I'll just show you what happened. So he has collected some 1,000 patients and followed with them for around 2 years, and has completed, like nearing completion. He's completing his PhD thesis, and he's supposed to publish the second paper, and he messed up with his Excel sheet. Now what he did probably was that he wanted to work on the Excel sheet on some patient data, and he selected this, and Excel gives you tools to sort it out. You can see the sort and filter function right up there. So he wanted to sort this out in terms of age or something. He was working on something. So he tried to sort this. Now Excel is kind, so because it's a spreadsheet, it still kind of understands that, okay, these are data put together which are together in a single box. So probably it is some kind of a table. It has some kind of understanding. So it gives you this kind of a warning. It says expand the selection or continue with the current selection. Now let's see what happens if you do with expand the selection. If I say sort this by expanding the selection, you can see that the colors are still intact. Now the order of the patients which we are arranged in SRC 1, 2, 3 and in the ascending order, that has changed, but the orange line is still there. So Excel kind of understood that it is a kind of a table, and it wants to preserve that relationship, that one row is a particular patient's data. So it has, when it arranged these in ascending order, it has arranged and pushed the entire row instead of just that. Now there are two ways this can go wrong. Now I am going to go back. I am going to press Ctrl Z and I am going to go back. Now there are two ways in which this can go wrong. Let's say you tried this and then you try to sort it and then you ignore this warning, or for some reason you select the second warning and then you say OK. Now what has happened? Can you see? What has happened? Now it has sorted this one, but remaining ones are all the same. Now patient number 1 was actually 71 years old, isn't it? Now that has moved here, and this has completely messed up the data. Now this is exactly what happened with our PhD student. 1,000 patient data and he didn't have backup. Now it is very difficult to unmess this, especially if you don't know on which row it was sorted or when it was sorted. It is very difficult to unmess this. Luckily, somewhere, some time back, he had emailed one of the Excel sheets for verification, but after that he had done another 10-20 hours of work on that Excel sheet, but at least we were able to get that version, and then he could repeat this 10 or 20 hours of work and then get back the data of 1,000 patients. But this could be very costly. If you realize it, you may correct it. If you don't realize this, you are going to end up getting the wrong result and publishing the wrong results. So this is one way in which you can go wrong. If you don't understand or in a hurry, you kind of sort it and then don't include the entire selection. Now there is another way in which you can go wrong. I can see that I have deliberately left this BMI column, which is a calculated column, empty, because in Excel we preferably don't enter calculated columns. We simply take the parameters needed for calculating a BMI, which are weight and height. So we just enter the weight and height and usually use a formula to calculate BMI. You don't have to type in everything every time. So let me just remove this for demonstration's sake, and let me again try to sort this using Excel. Smallest to largest, it gives me the warning. This time I do the right thing. I expand and sort it entirely. Now what happened here? It did that, but there's a gap here. So Excel thinks this is separate and this is separate, right? But for you it is the same. For Excel thinks because there's a gap here, this is separate. It has done the correct job. It has sorted the entire row there till whatever it can see. But then because you left a gap there, it didn't do that same thing for the later part. And now this is even more difficult to spot. It's even more difficult to spot, especially if you have some gap, let's say after this STUV, whatever 16,000 columns we have. Let's say you have it in the 16,000th column. Then you might actually end up not realizing that it is a problem that has happened, and again you will end up analyzing and giving the wrong results. Now how do we solve this problem? So straight up, when you build such a table, when you build such a Excel sheet, I recommend you to use Excel table. That you can see here in the next one. It's the exact same thing. But now you can see some new features. First thing is, in the ribbon, in the sheet you wouldn't have had this table design. Now because this is a table, you have some special options to edit these tables. You can see that in the spreadsheet you don't have anything on top here. Whereas when it is a table, you have special table specific tools that are available, which you can change when using tables. And the other features that you see is the sort that we are doing from on top somewhere, from home tab, and then we go here, and then we are doing sort for age that we saw that you saw me demonstrating. It's all available with each column here itself. So Excel, when it makes a table, it gives its best shot to identify the data types on its own, and then it most often gets it correct. For example, you know that this is a text data, so it can't be average, it can't have increasing or decreasing order, it will just have A to Z and Z to A. So and if you want to filter them, you will have text filters, that is, it contains this letter, it contains this word. Whereas when it is a number, it will give you options like number filters, and it will help you sort it out by smallest to largest. And also at the same time, when you want to remove filters, once you apply a filter, let's say I want to select only group 1, then I can apply the filter, then you can clear the filter right away here. So a lot of new features are available on table, but the basic problem that we discussed, let's say you sort this by age, it will always sort the entire row. It will not even ask you. It knows that you have marked it as a table, which means from that point to the point that you marked it as a table, it is going to be taking it as a single solid table. So if you properly make the data sheet, when you start making a master chart, if you straight away use a table, I'll show you how to do that, then you will be saving a lot of time later on. right? So let me go back again, and this case where I showed that, where there is an empty column, see, you can see that when I deleted the name BMI, it still allots its own name. So whatever, even if you leave empty space in between, it will give its own name. So it means that table recognizes that this is a particular part of the table itself and it is not a separate thing. So even if you delete the name that you have given and try to sort it, even then you should be able to sort the entire rows together. So I cannot emphasize how important this is for thesis data management. These very tiny steps which you take right up can save you a lot of time later. And again, table gives you a lot of other flexibilities also, which we will not be going into, because this should be enough for you to be convinced, right? Are you convinced better than a spreadsheet? So I want all of you to start using only Excel tables. So that one master chart you are going to make, it's going to be an Excel table and not a spreadsheet. Again, there are a lot of corner cases where we'll need to build some complex data forms that we are not going to cover today. So that was tables versus spreadsheets. So the first key take home point for you, always use tables. Do not try to work with spreadsheets, try to use tables alone for your purposes. Now the next aspect is more related to the data that you are going to, now how you are going to enter the data. Now all of you are going to be collecting some hundreds of samples or tens of samples depending on the type of study you are doing, and you are going to be entering them one by one into the Excel sheet, right? But there are some rules you have to follow right from the beginning. That is, each row should be a particular patient. Like I already demonstrated in the demo, each row is a single patient. Like you should not have a single patient's data spill onto the next row. That should be very clear. Whatever you want to enter, you have to enter in the single row. Now we will run into problems when you are trying to do that with some kind of data. We will come back to that. But remember this rule, one row means that it should be related to only one patient and it should not get repeated. You should not put it into another column, you should not mark anything in between, nothing. Don't leave empty rows in between. One row should be one patient. Second one is each column that I demonstrated. Each vertical thing is the column. Each column corresponds to only one type of variable. Like you saw in the demo table, age. The entire column is just age, and it should have the same unit. You can't simply write age in years for one person and months in for another person. Let's say you are dealing with pediatric data and then you have babies ranging from 11 months or 20 months old to 10 or 11 years old. You can't write 12 months in one place and 12 years in one place. So you have to be clear on your units and decide on one unit. If you're going to write it in months, the entire column should be only in months. And if you are going to write it in years, it's going to be only years. You can write it as 12.1, 12.2, you can decide how you're going to write it, but it can't be in months. It can't be mixed up, right? So that is another important part. Now, when you try to do this, there will be a situation where you are going to run into problems. This will be when you are trying to enter the same kind of values again and again. Let's say you are doing a study where you want to follow up creatinine of a particular patient. Let's say at admission you have a creatinine and you want to see whether the patient is developing any CKD or renal injury later, and you are following the patient 3 times in the future and you want to enter the creatinine every time, right? So you have 4 different creatinine values. Now most often what they do, they write creat 1 and then below that they start writing creat 2. Now that's not how you are supposed to do it. What you should do is actually you create 4 different columns: creatinine 1, creatinine 2, creatinine 3, creatinine 4, and then start entering. So each patient will have only one entry in one row, right? So that should be your goal. Now there is some difference between this time series data, the way it is analyzed in softwares. There are situations in which you need to enter them in a different way, but again this is going to be a corner case and we will not try to cover that. For most of you, when you do this flattening, that is, instead of entering all the values one below the other, like you have in this spreadsheet, I have height, I have creatinine value. See, when the follow-up creat is, let's say 2.2, I cannot enter it here. This is wrong. Although you know that this is patient 1, even if you put the number as SRC1 here, you still will have problems with, I'm sorry, this is copy set. So even if you have the same patient ID, if you have entries like this, most of your softwares are not aligned to or tuned to pick this up. they consider one row to be a particular patient. Don't do entry like this. The correct way to enter will be creatinine on follow-up 1 or some name you can F1, follow-up 1 or follow-up 2 or something, and then write it here. Write it here and not here. So this should be very clear, right? So what is the second rule that we learnt? Each patient should be in one row and one row alone, not more than that, right? And each column should be only one variable and of the same unit. Now there is one more example there. What I meant by only one variable is, let's say, I think most of you will have probably BP recording in your data, right? Now BP is measured like this. Now does this follow the rule that we mentioned here? 120 by 80, that's your BP, right? I mean, are you going to enter it like this? You shouldn't. What I mean by one variable, one column, one variable is that you should split it into two, and this should be systolic BP and this should be diastolic BP. So any complex data form that you have should be entered like this in its elementary form. So am I clear on that? So the row and column rule is the most important, second most important rule that you need to learn after the differences between table and spreadsheets. So I'll be running through some demos and show you what a bad master chart looks like. We already have that on the demo sheet, and I'll show you what a good master chart in the end should look like, right? So this, the next aspect that we come to is the variables, the names to the columns that you have given. What are the rules that you follow there? Now it is good to, there are many things which are essential here and some things which are good to have. I suggest that you follow all of them. It's quite easy to follow. So when you name a variable, try to use some convention, some rules as to how you name a variable, right? Don't try to name it anything that comes to your mind. Don't use special symbols. The simplest way to remember is, all of you are familiar with email IDs, right? So you know how an email ID is structured, right? The part before @ has a certain structure. You cannot start it with possibly a number. You cannot use star or something in that, right? Simple rules is it should be all small letters. Connect them with underscore. Don't leave any spaces. So that's quite easy to follow. So try to structure your variable name so it has a clear meaning and it follows this email naming rule. That is, no space in between, no caps, and underscore in between. Now is this rule to be followed absolutely strictly? You can relax this on you can relax a bit, but I suggest that you follow these rules so that if you are if your person who is analyzing the data is using some software, it can actually mess up the variable names, and when the result comes back to you, you may not be able to understand what exactly it was. So the next part is encoding data. Like we saw the summary table, right, from the research article that I showed you. So each one is summarized as an average or a standard deviation, or when it is counting, then you summarize it as a percentage. Now when you have categorical variables, you better use something known as encoding. Like instead of writing gender, male, female, female and typing it every time, it is better to have a code which is simple to type and also easy to analyze on machines. For example, male and female, one of them, like female can be 1 and male can be 0. It's up to you. There is no strict rules as to who has to be 0 and who has to be 1 and all that. But you have to make a note of it. Whatever you have used, you have to make a note of it in a separate sheet called the encoding sheet, or you can label it coding or encoding or something. Now how do you create this sheet? You create this sheet after you finish making your master chart. What you simply do is you go to this first row, that is your variable name, press Ctrl Shift right arrow. Because it is a table, it goes and stops exactly at the right end of the table. So Ctrl Shift right arrow, you are able to follow. Then you press Ctrl C, that copies the entire thing. Then what you do, you go to the encoding table. I am just going to paste it here. You paste it here, right? So this is exact replica of the row that you had in your final master chart. Now right below it, you start writing your codes like what I mentioned here, right? So if gender is 0 is female and 1 is male, you can make a note here. And here in this study, there are 3 groups of patients that you have studied. Group 0 will be normal patients, group 1 is hypertensives, and group 2 is CKD. You may have other groups in your study, so you make note of the code that you have used, and this is very important for you to interpret the data later on. So when you send it to a statistician and it comes back, you have a summary table which says you had 200 patients, 30% are hypertensives and 40% are CKD and remaining are normal. So, but if you have encoded it, it will come as the number of zeros in it is 30%, number of ones in it is 40%. So, if you don't know what is 0, what is 1, you don't know how many hypertensives you have, how many normal persons you have, right? So, when you have this encoding table, you can understand, okay, number of zeros is 30%, so it means that normal population is 30%. So, that's how you use the encoding table. There are other uses of encoding table, but I will not touch upon those aspects. It is very helpful to automatize data analysis if you have a proper encoded table, but we won't touch upon all those parts now. So, the types of variables I think we have already touched upon, so I will be skipping this part. So, one part that I just wanted to tell you is that when you have data, categorical data, you can have things like gender where you have male and female, and you have some other data which behaves like categorical data, which is known as ordinal data. In ordinal data, you again have groups. So, ordinal means ranking, all right. So, let's say you have NYHA class. I hope you understand NYHA class, right? So, when you have NYHA 1, 2, 3, 4, you know that 1 is not as bad, but 4 is really bad. So, you have an order like 2 is worse than 1 and 3 is worse than 2 and 4 is worse than 3 and all that, but they are not actually numbers. You can't do 1 by 2 or 3 by 4 or something. So, they are not actually, they have some sense of order to them, but they are not actually true numbers. They are 1, 2, 3, 4, but they are just some ranks. They don't have any equal distribution or anything. Those are known as ordinal data. The other point I wanted you to understand is that any numbers like age can be converted into categorical data later on. Now, the prime example for this is age group. Okay. So, many of you will be maybe comparing what happens in less than 40 age group versus more than 40 age group. I see many of you struggling trying to build another column for it and then start entering data as to more than 40 or less than 40 one by one. Actually, there is no need to do that. You just enter the date, and it's easily doable when you have a proper analysis software into categories. So, it will automatically categorize it into less than 40 and more than 40 using simple formulae. So, numbers can be converted into categories, but not the other way around. So, when you want to, even if your study objective is to study only 2 age groups, let's say your study is to compare tobacco usage in less than 40 versus more than 40. So, that's your study, that's your primary objective, and you have decided that I want only information on age 40, more than 40, you enter only 40 less than 40, more than 40, that's it. Then you, at the end of the day, you find that okay, there is nothing that turned out, and you don't remember why you chose 40 years as the cutoff and why not 50 or 60 or something, and then you wanted to think, yeah, in women we should have chosen 60 because elderly women, because of that some generation they smoke, and then you want to get back the age. You can't get it back, right? So, when you have a numerical data, you enter it as numerical data. All the grouping you do in the end. Don't do it right up, right? Even if it is a numerical data, even if you are interested only in 2 categories in the beginning, try to enter the actual number instead of the category straight away. So, the last aspect of variables is the calculated variables. I already mentioned it briefly. That part is the BMI one. I will just go back to the demo data. So, you can see that here I deleted that. So, this is where we want BMI. So, we have the raw materials for it. We have a height and weight, and then we want to do the BMI here. Again, no need to calculate one by one and enter it. And what about the formula? Everybody knows that it is weight by height square, right? Height should be in meters. You could have entered it in centimeters like this, but height should be in meters. Now, how will you know Excel formula for this? Anybody, can you tell what will you type in this box here? Formula starts with equals. Can anybody tell me what you have to enter here to get a BMI? So, luckily for you, there is no need to memorize anything. These days you have ChatGPT, right? Right? You just ask for Excel formula for, you have another wonderful tool called Formula Dog also, but ChatGPT is good enough for these. Formula for BMI. Let's see what it gives. So, you see, it gives you the Excel formula straight up, right? It tells you, it gives you an explanation. It tells you that it's going to be starting with an equals. It understands that Excel formula starts with equals. and it has to have weight and height square. Now it gives you even this one. See, even if you have missed it, it even tells you what you have to do. And it's assuming that this contains this and this contains this, you have to do this. So let's try to do this. Let's try to copy this onto our sheet. Now we know that now A1 is not actually this thing. We'll select this one, the corresponding one, that's height, and we know that weight is going to be, this is going to be weight and this is going to be height. So our formula is ready, right? So what happens? Do you think this is actual BMI value? No, the reason is because height is in centimeters. Now what do? Either you can figure it out, go back to your high school math, or ask ChatGPT again. What if height is in centimeters? See, most of the work is done for you these days, isn't it? I used to sit down and write formulae for GFR on my own. Now imagine my plight. You've seen CKD or MDRD formula for GFR, with all the exponents. You used to write the entire thing down. I actually have those files with me, but now it's all so easy. So let's go back again. We'll select everything, we'll delete it, and then we'll copy the formula here, right? Now it says error because of course A1 is not weight, B1 is not height. So we change that and then we press enter. Now it's all right. Now you see that BMI is in range, right? You can verify that everything is in range. So that's how easy it is. Like you can do that for body surface area or anything. If you don't know, if it's not a general enough formula that ChatGPT doesn't have answer for, you can actually type your whatever you want in the formula or copy paste the formula into ChatGPT, or another website called as Formula Dog, which is specifically for generating formula for Excel. You can see that I have tried to generate a formula for body surface area and it has given me the most commonly used formula for body surface area, right? So you can use either ChatGPT or you can use your Formula Doc for coming up with formulae. Now the important aspect is once you are done calculating, I will come back to that. If you have seen that when it is an Excel table, I entered the formula only here, I didn't do anything, I just pressed enter and it knew that the entire column is going to be the same. So automatically as soon as I pressed enter, it applied the entire formula to all the rows on its own. I didn't have to do copy paste or anything of that sort, right? I didn't have to bother. So that is another advantage of having a Excel table. Now the important aspect here is it is good that if you can convert this to numbers. Right now it is all formulae, but it is better, like you may insert another column here or something. Excel does take care of those mistakes also, but to be safe, I suggest that you select the entire rows and do a Control C and we write there, right? Once you can see that now entire thing is a formula. Once I do a Control C V right here, it gives me option to paste in different formats. I want you to focus on the one which has 1, 2, 3 below. It says values. So once I press this, now it has copied the numbers, right? So there are only numbers here. Now there is no formula. So once you have done calculation and you have verified, then you can just convert it to numbers and save only the numbers, right? So this is about using formulae in Excel. Now the other advantage of Excel table that I wanted to show you was, when let's say you are trying to enter a 100 patient data, you can see that here only some 5 patients are there. Let's say this is a spreadsheet, this is not a table, this is a spreadsheet, and I want to enter 100 patient table, I want to enter age. Where do I enter? Right, I want to enter age of 50th patient. Where do I enter? I can't see which column is age, right? I can't see which column is age. When you use a spreadsheet, it doesn't recognize that the top row is a variable name. Whereas when you use table, no matter how far you go, as long as it's within the table. So let's say you have entered some 120th patient's data. Now it automatically made it into a table, and no matter where you go, like I am entering the 78th patient here, you can see that the top row variable name has been taken here. So you can easily know as you are entering that this is the row in which this is the column in which I have to enter age. So this is another neat advantage of having a Excel table. Are you able to follow so far? All right. Should I move on, or you want to practice something for 2 minutes? That we'll do that as an exercise in the end separately. So yeah, so now we have come to the end of, I think, 75% of the presentation. So most of the important points that I wanted to cover was about using an Excel table straight up, using following this rule of one patient, one row, and one variable, one column, and following some important conventions when you choose a variable name, how to work with data in Excel, how to enter. We have seen that through practice. We have understood what are the variable types and what kind of problems you may run into when you try to follow these rules. Now we come to the last important aspect of today, the data validation. Now I've seen very few people use this write-up, but I strongly recommend that you understand what is data validation and straight away start using it when you build the Excel sheet itself. Now we are going to do that as an exercise. If one of your performers, I am going to try to make it into a proper Excel table so that you can start entering. We'll do that exercise as the last part. But before that, I want you to understand what is data validation. Anybody has any idea what is the data validation? You know, what is the most common error that we face when we see Excel thesis data other than the way it is arranged or made? Like most of the times you may get guidance on to how to make a master chart, okay master chart. But then after that when we start analyzing, the most common error that we face is data entry errors. You know, so I'll demonstrate that and I'll come back to this data validation part. So can you identify the mistakes? We have discussed a lot of things right now. I want you to now spot the mistakes that are there in this master chart, which makes it a bad master chart. You can just, you know, one of you can just start telling out aloud. Exactly. So this patient has more than one row, right? This is serial number 1, but then for some reason, I think, yeah, again because of creatinine, they entered it in a separate row. So that is one. Then what about this? What is this variable name? It's an entire question. You know, it is like, what is the final ECG diagnosis? That's you know, that entire question has been framed as a variable name. This is a very poor practice. Now this is what we discussed. Now these are good. Even if you don't use small letter, it doesn't have a gap, it clearly tells you what it is. It could have been final underscore ECG underscore diagnosis, isn't it? It need not be this, and this will cause problems with some of the analysis software. So be very careful when you choose a variable name, especially avoid this. And this again, it's again a poor variable choice. It has brackets in it, and it has forward cross in it. No, we don't want to use these extra letters in the variable name, right? And another mistake that there is, you can see, is this entire row has been used as additional information for the variable name. Again, don't do this. Your entire variable name should come in a single row, right? Should come in a single row. And I suggest that you start your table right here, but it is not necessary. Excel table can be anywhere, but it's good practice to start the Excel table here and then have it somewhere end in the right corner, right? So those are some of the mistakes. Any other mistakes that you can spot? Any other mistakes? Can you come to the age column? Right? You can see the age column here. Is this a way to enter age? No. What should it be? It should be just 49, right? Again, when you start entering like this, there are many errors that will creep in. Like somebody will write years as YRS, somebody will write capital Y, all capitals, or spelling mistake with years or full years. All this should be avoided. We just want the number there, nothing else. Just the number there. It should be just 49, it should be just 55, and that's it. It's like that. And similarly, when you have gender, you have male in small here, capital M here, single letter M here. Similarly for female, you have full female, and then you can see the example that there is a capital F down there somewhere and all that. So these are inconsistencies in entries. What happens if you enter it like that? Like, we are able to understand, capital M obviously means male, right? We are able to understand, but when you try to summarize using some software, when you analyze or statistician analyzes, it will tell you that 80% were males, 18% were females, 5% were M's, and 3% were F's or something. It doesn't make any sense, right? So that is why you should avoid all those. Even better practice is to just encode it into 1 and 0. It makes your life easier. It's simply 1 and 0s that you have to enter. It makes it easy. You don't have to type the entire thing when you enter. That is also acceptable, but you make sure that you have noted it down in the encoding sheet down there. So that is another error. So can you spot any other error here? Any other error? You can see that, meters entered here. You can see that CM written here. We don't need this actually. We just need the number 153, right? Similarly, in weight, you have this problem and all that. So these are common data entry errors that we see in an Excel sheet, which makes it quite difficult for you to, produce good results. And more importantly, when you try to go to a statistician where already they have limited time and your guide has limited time, and you go with these mistakes, nobody is going to have the patience to help you out. Like, hundreds of people will be rushing to a single statistician. Now you make this mistake, they are not going to sit and correct this, right? They will have 5-10 minutes for analysis of one sheet. They'll have a nice method rolled out, but then they'll end up seeing this and they'll send it to you back that correct the master sheet. Or worse is that they may make some changes, it may not be correct, right? They may make some changes which may not be correct. That is even worse. So the other thing that I wanted to note, the other common data entry error, this one, can you spot? IVC again, it's inspiration and expiration time, but it's all a complex data type should be entered in 2 separate columns. So let's see this one. I'll just select the entire potassium entries, and I want you to look at the status bar and tell me if there is any mistake. You know what the status bar is, right? What is the status bar? What is the status bar? The one below here. What is the average potassium here? What is the average potassium? Can your study have an average potassium of 8.5? It can't, right? I mean, even if you are studying hyperkalemia, probably you won't end up with this value, right? So obviously something is wrong. So can you spot the error in this huge sheet? It's quite difficult to spot, right? It's quite difficult to spot. What is here? What is going wrong here? See this? How can somebody spot this error, right? It's very tough. It's you know the answer. You know it's 5.2, right? But it's been entered as 52 because you missed the dot, or your computer, keyboard is not working or something, and then you entered like this. There are many more data points like that. So you entered 52 instead of 5.2. So that's a big mistake. It will give you wrong values. Now this is the most grave error in doing any research, giving wrong results. So we should not give wrong results. Even if you don't publish paper, it's an acceptable practice. But don't publish wrong things. At least I don't want you to be ignorant on these aspects. You should be able to produce a very good quality data. So at the end of the day, we want a master chart which has quality data, which can be readily analyzed by the statistician or whoever you are taking help from. So this is what brings us to data validation. Now, is there some way in which I can try to minimize these errors? You cannot completely avoid them. Can I minimize these errors, data entry errors, right from the time I enter my first value? Yes, that is by using something known as data validation. What I'll do is, I'll show this aspect as we build the proforma for one of you. Does anybody here have their proforma available to fill? Any single person who has at least one patient's data, so that we can build an Excel table. So that will be the last part of the class today. So we're going to make an Excel sheet using a proforma. Any person. We're just going to try to help you with building up this thing. You can just come up here and build the table along with me. I just want proforma because I assume that most of you will be starting out to enter the data, so I want the proforma. Any proforma is okay. Your name? Would you like to come up here to build the table? That's okay. introduce yourself.
I'm Ruchita Arthanani from Department of Anesthesia.
So anesthesia is where we actually get complex data types. So corner cases we'll have to discuss with her later. Anyway, so this is a brand new Excel worksheet. You can, label it master chart. Right? Now we are going to build a master chart, not for the entire thing, the most important aspects of it, to understand how to build it so that the first value you enter itself is of good quality and then you minimize your errors, right? So can you just read out what are the aspects of it?
So the title of my study is Surgical Plus Index to predict the success of caudal block in pediatric patients under general anesthesia. So I'll be collecting the general demographic data, age, sex, ASA 1 or 2 patient, weight, height, BMI, then their provisional diagnosis, proposed surgery, duration of the surgery, and then other caudal block details.
Alright, so we'll build a table using some of the variables which will demonstrate how to, the important aspects of building a Excel table right from the beginning, right? So I hope you're familiar with a proforma, right? Most of you have a proforma like this, I believe, because you're in second year and you're already halfway or completing your studies, right? Right, yeah. So the first thing, of course, you should have a first column always should be the study number. We'll simply call it serial number. You can call it study number, study record number, or anything you want. So I just named it SL_NO, serial number. Easy, simple to understand, no spaces, no special characters, no capitals, right? So I move on to the next column name, that is date of surgery. So because it's your study, you know that there are only 2 dates that you're recording. She is recording date of admission and date of surgery. It could be date of discharge or date of death or something else also for you. But because you already know date of admission, you only have 2. So you can simply write DOA, which means date of admission for you, and DOS means date of surgery, right? So I'm just writing the few of the variable names to demonstrate the various variable types. You can type along with me and try it out so that when it comes to your proforma, you can also build the same Excel table. The next one is the age. Again, all small letters, age. Would you like to try? Yes, go to the next column. You can use arrow marks or tab. Yes. So that is gender. The next one would be, could you explain what is that, ASAPS?
So it's the ASA status of the patient 1, 2, 3, 4, 5.
So
for my study, I'm only choosing ASA 1 and 2 patients.
So otherwise it would have 5 categories, is
Yes.
it? So now is it an ordinal variable or a categorical variable?
Sir, ordinary.
So it's an ordinal variable. So there is some sort of a rank here. So ASA, you can think of it as rank 1, 2, 3, 4 or something, or category 1, 2, 3, 4. 4 means worse.
Yes, sir.
4 means worse, 1 means not so bad, right?
1 means a healthy patient.
1 means a healthy patient. So
No comorbidity.
alright. So there is an ordinal variable also here.
ASA
Status, yes. So that's a good variable name, right? ASA status. You know that it is going to be a categorical variable. It will have only 5 categories. It will be 1, 2, 3, 4, 5, or it may have no entry. You don't know the status. For some reason you didn't record it, or it got missed or something. You don't have the status. And the key aspect of missing data is leave the cell empty. Don't try to make any entries there. Just leave the cell empty. Whoever the statistician is, they'll know how to handle missing values in their softwares. So don't try to add some number which will add confusion there, like 99 or something. Just leave it empty. Just don't enter anything there. Empty means that the data is missing. That's it. So we'll go with weight, height. BMI is a calculated column, right? And yeah, provisional diagnosis. Now what do we do with this provisional diagnosis? So your study will involve all sorts of diagnosis,
Yes, sir.
right? So is it like 5 or 10 kind of diagnosis that you'll commonly encounter, or it's going to be any number?
No, sir. 5 or 10 generally.
Yes. So when you have a situation like this where you have a provisional diagnosis and you know upfront that you're going to take 5 different kind of patients only, like can you give some example of 3 different categories?
Like I'll generally take proposed surgery like herniatomy,
Diagnosis, you can tell diagnosis.
hernia, umbilical hernia.
Umbilical hernia. Just couple of them are also enough.
Femur fracture.
Femur fractures. One more?
Okay,
Tibial fracture. So let's say these are the most common, right? So provisional diagnosis is umbilical hernia, femoral fracture, and tibial fracture. And others are, you may have one case, you may have two cases and all. The way to enter it is, if you know that, these are the three most common diagnoses which will cover 90% of my cases, just have three categories for that. Just have these three categories, and the fourth category you write as other, right? Straight up you enter as other. So, but then you are losing information, right? What is this other? If you want to analyze it or you want to write some paragraph about it in your paper, you write details. Provisional diagnosis, you write details. So this particular rule, this particular column will have one entries or description only for those rows where other is entered, right? If it has umbilical hernia, it will be empty. If it has tibial fracture, it will be empty. If it is other, you will write something like skull fracture, something like that, right? So you may write more details also, that's up to you. But when you have such a thing, and if you can identify the most common 4, 5 or 6 groups, try to put those in clear terms which will cover 80 or 90% of your cases, and the remaining you categorize them as others and write the details down, don't forget. Do not miss additional information, write them down. So next one is proposed surgery. So this I will skip because the way you are going to enter it is going to be the same thing. It's going to be hernia surgery or femur fracture surgery or something. So the same principles follow. You will have 2 separate columns for it. Now duration of surgery. You can use something like simple things like surgery duration, right? So you enter variables like this, and I'll skip through to some other variables which are, so she has an entire table which is time series data. That is what I was saying, when it is anesthesia, we will have this corner case where you have every 5-minute monitoring. Now the ideal way to, it depends, like there are other ways to enter and manipulate this data or analyze this data also, but we are going to follow the same rule, that is, she is actually, what is this time after incision? So she is monitoring the BP, heart rate and other vitals every 5 minutes after the incision is made, right? So she has up to 2 hours. So how many measurements will be that?
20.
So 20 measurements, right? How many columns will be there? How many columns? 1 or 20?
1 per patient.
No, not row. How many columns? It will be 20 columns, right? It should be something like time after incision 5 minutes. So BP. So you are going to measure first of all SBP at 5 minutes, right? This is going to be 1 column for you. Then it's going to be SBP or DBP. You can finish the 5 minutes one close together because all of them will be here. So you can enter DBP 5 here, right? So I'm skipping the heart rate and all that. I'm going to the next measurement. So it will be SBP 10, right? And it will be DBP 10. So got it? So I just put only couple here, but her measurements actually start 0. So it will be SBP 0, SBP 5 all the way to SBP 120. So that is how I recommend to enter the data, because most of the softwares can handle data like that. But there are specific objectives for which you can enter it differently, but that we are not going to touch today, right? So I think this covers most of the data types. So thank you. So this covers the most important data types. Now we have entered only the first row, that is the variable name. So now once you have this, let's say you have finished entering all the column names. What I want you to do is go back to the first cell, hold Ctrl Shift down and press right arrow. Keep pressing it till you come to the other part, like other end, and hold on Ctrl Shift again, select one empty row, just press Shift, Ctrl Shift to the end, and then only shift one row, or you can select it even like this using GUI if you are not comfortable with keyboard. Have you selected all this? Can I get an S? I hope you are following all this, because you have to do the same thing with your proforma. Now after this, press Ctrl T. Have you got this dialog box? I want an S. Yes. So you can see that it has an option. You have already given the header, so tick this option. So what we are telling Excel is that this is going to be my table. So this is going to be my table, and I have given the headers. That is the first row. So once you do that, you click OK. Now see what changes happen. It became colorful, it looks nice, and then it has arrow next to each and every variable, because these are the ones which will help us sort and filter things out. And then you can see that it has recognized and put up a table design tab there, which means that it knows that it is a table. Now you can start entering data right away, right? Your table is ready. You can start entering table number 1, like date of admission is a date. So have a clear formula. The formula for, the style for date is always DD YYYY, right? So always enter separated by hyphen. For age, you can enter 65 or 56 or whatever it is. Gender, male, status 1, and then weight is 25, 50, and this one. So she has entered height here, so all right. 165. You can just fill up some values here. Provisional diagnosis is going to be hernia, and what are the details here? Provisional diagnosis details, there is nothing here because it's not other. Surgery duration 30 minutes. So when you have only 30 minutes, you won't have entries for all the minutes here. 120 by 80 was the BP at 5 minutes, and then it became 110 by 70 at 10 minutes. So you can start entering data like this, and most of you would have done this only unless you attended this class, right? But we are not going to start entering data like this because so let's say you are entering the next patient. You can see that once you enter another patient, it automatically, the table extends. You can see the arrow mark here. It automatically keeps extending the table as long as you don't leave any gap. If you enter the 5th patient here, it doesn't know that it is part of the table. As long as you don't leave any gap, it knows that this is part of the table, right? So don't leave any gap. Keep adding patients one row below the other without any gaps in between, no empty rows in between. So this is how you build a table. But then let's say you are entering a lot of data together, and instead of 63 years age, you double key press and 633. There is nothing prevents you from entering the data like this, right? You may or may not notice it, and it may come up to light when you are actually analyzing and writing up your results that your mean is actually somewhere around 100. That cannot be true, right? So this is the kind of error that we want to take care of using data validation. And then when it comes to gender, you have started entering, and then you have entered let's say 20 patients, and for some reason you are entering here and you are tired or you forgot, and then you started writing like this, right? It can happen. Or you start writing capital F for some of the entries. So you can have these mixed entries. So nothing prevents you from making this error. Now to prevent all this, what we are going to do is we are going to use something known as data validation. Let me just remove all the entries here. Now we'll start with simple ones, the numbers and the categories. Now what you have to do data validation is, this is a stage at which you will have your data table. I'm going to delete all these rows. I'm going to have only one row. So this is where we have not yet started our data entry. This you have just entered the variable names and you have converted it into a table. Now you want to add some rules so that Excel alerts you when you make a mistake. It will avoid a lot of mistakes if you apply rules to wherever it is possible, right? You know that age in your study, if you are recruiting only adults, it can't be less than 18, of course. And most often you are not going to have patients more than 100 or 99 or whatever. So you know the age range. So what you can do is select the single row below this one, and then go to this data tab up there. And then you go to this symbol here. Can you see this correct and wrong in cells? So that is the symbol for data validation. So when you click on that, it will ask you what are the rules you want to apply. So this is the dialog box that opens, and these are the criteria that you can directly apply. Now what will you do? The default setting is you can enter any value. You can write age as Ganesh. It will not stop you from doing that, isn't it? But then if you want data, good quality data, you know that you are going to enter age only as a whole number and not decimal. When you know that, then you write it as whole number, and you can give a minimum. It cannot be less than 18, and maximum 99, right? So let's go back and visit that error that we had. What is that? Instead of 63, you double key pressed and made it 633, right? Now you move on to the next cell. It will show an error. It will tell you that this value does not match the validation restrictions defined for this cell. What did we define it as? We defined it as 18 to 99 only. So it will throw an error, right? So you can correct it then and there, and then you can enter 63. So isn't this a neat way of preventing errors right up? Yes or no? Are you guys following what we are doing here? All right. So we kind of minimize this error. Why did I say minimize and not completely prevent the error? Like you can enter 36 instead of 63 for a patient who is 63-year-old. That's not going to get prevented, right? So major errors can be prevented, but not all the errors. So please remember that. It's not a foolproof method, but most of the time 70 or 80% of the errors definitely will come down if you use data validation setting. Now that is for whole number. The setting for decimal number is very similar. So I hope you understand what decimals are. And once you know the range, for example, I know that if I am entering ejection fraction for heart, it almost never is less than 10% and almost never is more than 75% in most of my studies. So I enter a value between the limits as 10 and 75. That's it. So for most of the columns that you use, except for free text data like details, PD details, most of the data that you use, you will always have some kind of a ranges in your mind. If they are numbers, it's better to write up, add those data validation in between. And this is a one-time exercise, because the next time you enter data in another cell, now here again you can try entering this. It has already applied the rules, right? This is the use of an Excel table. Now it knows that it is a table and this row belongs to the table. The same rules which apply to the cell above applies to this cell. So it automatically recognizes and lets you correct it immediately. Now what about gender? What kind of rules do we apply for gender? So data validation, you can see something known as a list here, because it's a list of values, like it's a list of categories. Now the source list, you can enter anything as simple as M, F. No spaces, nothing in between, just M, F. So you can see that there is an arrow thrown up here. You can directly press that and select one of the values instead of even entering anything, right? It is helpful when you build the table. Remember that when you apply data validation, you have to apply it to the entire cell. That's why I suggested that when you have only one cell, only one row in your table, right, then you apply, so that when you add the next patient, this would have already applied there, right? So all the data validation rules that you're going to apply, do it when the table is in this stage, that it is only one empty row is there, so that when you apply this, whenever you add a new patient, it's already there. So let's try something like provisional diagnosis, which is running very long, right? Now this makes your life easier here. By choosing a list here, you can choose hernia, again in between the words you can have spaces, but between two categories don't have any spaces, like femur fracture, no spaces here, tibial fracture, and others is what we decided, right? Other. So we made 4 categories here. Whatever is separated by the comma is a separate category. Now see how much it makes it easy for you to enter. Now you don't have to type out the entire thing, right? You simply have to select from one of the lists. One from the list, that's it. So you go to your next patient, and then that list is available to you. You can keep selecting. Whenever it is others, you write something as skull fracture. This you have to type because there is no way we can get around this, right? So this is about making a Excel table and data validation. Data validation can be even more sophisticated, but I don't think it's necessary to go into all the details. I'll just show you what it is capable of. Like SBP is going to be a whole number, and it's always going to be, let's say, between 50 and 300, let's say. And you can actually have an input message. So when you can either do it when you are entering, you can input a message, which is quite troublesome. You can have an error method which can say that out of range, enter value between 50 and 300 only, right? So this is what we have typed in this. So now let's try to enter some value, like let's say 50, it will accept, right? If you type 500, oh yeah, this we didn't. Whenever you add data validation, make sure that you've added when it is in the nascent stage, right? Now this should be not allowing us. So it says, see, it says whatever we put here, it says out of range and it says enter a value between 50 and 300 only. Now how is this useful for you? Now for most of you this won't be useful because you will be collecting the data and you will be entering the data, so you don't have to have this message. But let's say it's a faculty who's making a sheet, or you're a senior and you have a group project or something, and then you're asking somebody else to enter the data. Now this will be quite handy. So this is a one-time effort where you make a nice table with all the data supplied, so that whoever is filling the data, now data quality is ensured to a great extent. Again, this doesn't prevent you from entering some wrong data within the range, like the patient BP is 120 and then you enter something as 80, that's not going to prevent you. So it will not catch all the errors, but it will catch most of the ominous errors. So likewise, if you add a new column without a gap, if you just add a column name, the table gets extended to the new column along with all the rows that already existed. So try to build a nascent table with only one row in it and use these data validation rules, what you have learned today, right? And there are other options also in this. You can have date ranges, you can have time ranges, you can have text length. If you don't want to allow more than 5 letters in a column for some reason, that all these you can try out and enter. So basic idea is try to use data validation right up so that your entries have a good baseline quality to them. Alright, so this is about converting a pro forma to an Excel. Are all of you are clear on these aspects? So you will be able to, yeah.
Can we change the rule or whatever specification we want in the data validation after you have added some of the events? Like, can we change the value?
Yes, you can add it. You can add it. For example,
Like since this addition we added the names, what will happen to the data that has come?
yes, that is some aspect we have not covered today because our topic was our focus was to focus on only the initial part of it. But yes, you can add data validation to it. I'll just show it on a sheet which is already there, which is, let's say, partially entered. Let me make a copy of this. So this is a copy. So let me just erase these. This one doesn't have any data validation. Let's confirm that. So there are no data validation for weight column here. You have entered some values, like you have entered some, let's say some 2-3 values and some are empty or something like that. Now when you have an already made table, make sure that you scroll down a little bit till this variable goes up to the top row and changes color. You can see that instead of F, the weight has come up there. When you do that and you use this and you hover over the variable name, it becomes a short thick arrow, and then you press it down, it will select only till the end of your table. Now after selecting all these cells under the variable name, then apply data validation here, right? So whole numbers, again between weight should be maybe 20 to 200, let's say, and then press OK. So once you do that, then what it does is it will take the validation, the entries that you have already made, nothing will happen to them, right? But it will flag it because we don't have anything out of range. It's like this low. So let me just select all the cells, apply a data validation. Just for sake of demonstrating, I'll just put a cutoff of 50. Now you can see that it has thrown up some errors. You can see this top left corner of each of the cell has which has errors, which is out of range, is flagged, right? If you already have entries there and this it flags it with a small green arrow. If you hover over it, it will show that there are errors here, data validation error here, right? So you can go back and correct them. So actually I use this trick to check sanity of entry in people who come to me for data analysis. When they give me the Excel sheet, I use this trick to actually check whether they are in ranges, right? For example, you come to me and then you give me an Excel sheet which is not a table, which is a poorly made Excel sheet, and then you ask me to analyze it. I want to check whether your data is okay. I randomly select some columns. I know that some things like this will have ranges and all that. Potassium will have a range. I select these cells, put data validation on them, and none of them should get flagged. That means you have entered it correctly. So that's a way to error check. So the question that you asked is, can we do it later? Yes, you can do it later. Select all the cells. Select all the cells and apply data validation. And whichever is flagged, check the values again. That's it. Does that answer your question? Yes. So these topics are a little advanced and not for today. So I think we are wrapping up. So the good practices that we learned today are, always use Excel tables. A lot of advantages, you already saw it on hands. Use intuitive variable names, follow some good conventions. Use data validation wherever possible. Sometimes it's not possible to use data validation. For example, when you have like the surgery details, like when you have another column, you can't really have validation for the other one, right? You have to have free text there. So you can't have data validation for every particular column or variable, but wherever possible, try to use data validation. The other important aspect is always use backup and version control. Always use backup and version control. I'll just show you the name that I use for Excel workbooks. You can see that the entire study name is there and version is there, right? That tells you that this is the latest version, the highest number, whatever you have in your folder is the latest version. And then you can work on that Excel, and then if you make some mistake and go back to the previous version like 3.0, and I write down in a separate text file that from version 2.8 or whatever to there is a major change, and that's why I made it version 3, and I write down what is the change that I made. I added few columns, or I added 50 more patients or something like that, and I have a version control. So you can have your own ways of doing it. This is mainly to ensure that your work gets saved. Always have backups. Nowadays you have cloud. Put your file on the cloud and keep it safely. Make sure that you have a secure password and all that. So put your file on the cloud and use version control. If you end up doing 3 hours of work, you should not repeat the 3 hours of work. That is how version control helps, right? Have copies and you don't lose data. Like sir rightly mentioned, like after you don't save your work. That's like it's a very simple thing, but it's quite painful because you have to repeat a lot of work. Again, version control and backup solves that problem for you. And the last 2 aspects is, do an interim analysis, like you have 150 or 200 patients to be entered. After you enter first 10 or 20, run through your entire file, make checks, see whether your data validation entries are all okay, or the ranges are working or not, any problems, any columns that you missed, any other details that you need to add. All this you do a check after doing 10 or 20 entries. And whenever you use Excel formulae, make sure that after you enter the formula, you randomly select some 5 or 10 cells and verify it yourself using a calculator that's how exactly the value is supposed to be. So all these practices you have to strictly use. And for a good student, it is better to understand some basic aspects of how data analysis or data analysis is done and how common statistical tests are used. Now, if you can understand that, you will have a much better master chart and much better handle of your research project, and you will be able to write very good results and discussion if you know these aspects. So I think with this I'll conclude my session. Thank you for your patient listening. Anything we want hands on, any particular data type that you had that is difficult to enter, or any mistake that you made which still I have not covered. Yes. Yes. Yes, of course you can. Like let's say you are looking at heart symptoms, and there are only few symptoms that you have. Like let's say there are 4 symptoms that you are interested in: shortness of breath, chest pain, palpitations, and syncope. Let's say these are the 4 symptoms you are interested in. You can label them as 1, 2, 3, 4. Just make a note in the encoding. When you have this encoding data, let's say you have chest pain. Symptoms. So in this coding, you make sure that 1 means chest pain. I am not writing the full thing. 2 means shortness of breath. 3 means palpitations. 4 means syncope. So you can add it like this, and you can enter only 1, 2, 3, 4. But because you have data validation, you can use lists. When you are entering, especially when you have a lot of variables, you may not remember the codes, right? So that's another that's an added advantage of data validation. When you have long things like this, you put it in a list. You just select it from the drop down, like we did here. So if you have symptoms, it is better to, when you have something like that, it's easier to select like this. For you, it is easier to enter. So that's the advantage. Like, you don't have to remember, okay, what was hernia? Was it 1? Was it 2? You don't have to go back and forth between encoding and this. When you have data validation, do this. And later on, when you analyze, it can be easily accommodated by any of the software which is used for data analysis.
So in the table, can we increase the first column?
Yes. So another problem, so now we saw row-wise scrolling and the problem that can happen with row-wise scrolling. But for some reason, let's say you want to compare, let's say, here you have 5th minute BP and 120th minute BP, right? Let's say you want to compare those two, and your 5th minute BP is here and your 120th minute BP is somewhere down the line. So when you have something out of place like that, so I'm going to just drag it here to whatever, it automatically names it. Let's say you want to measure the 60th measurement and the 5th measurement, and you wanted to compare and see whether you have entered it correctly or not. Now, for this particular patient, you can either mark the row like this and then go on and on and on, and then select the 60th one and compare. By then, 5th is not visible. Instead, what you can do is, next to the 5th, you can select this particular column, and you can type freeze in the search box, and then you press freeze panes. What it does is, it behaves, so the part before it gets frozen, and then when you start moving it, it moves only that part. Right? Now you can easily compare the 60th value or 50th value, whatever you are interested in. Now you can easily compare by putting them side to side. So this is for the vertical scrolling, right? So to unfreeze it, what you do is simply press unfreeze here, unfreeze panes, and you're done, and it's back to normal.
Any other question? When you had taken up to that 70th one, chosen everything to find the data validation. After that, you may start entering up 71, 72, 73 to work. Like it wasn't the nascent one.
Yes, ma'am.
There were 70 entries.
Yes, ma'am.
Then you put the data validation. For that, you chose all the 70 and put the
Yes, ma'am.
The 71st.
Yes, it should work. It should work. I think I understood your question, ma'am. So I think you were So here you were asking, no, ma'am, when we already had a partially filled chart, and then you entered an additional patient there. Let's say this is SRC 54. So it should have. So weight, the column, you can see that it's highlighted, and when we go here, and we had put 50, I think. So if you put 56, it should flag it. No, it's not flagging it. Yeah, I think you'll have to again do that data validation as you enter more columns. So in between, when you have a partially filled data sheet, it's actually more of a headache. So we suggest that we start with good practices straight up. Yes, ma'am. Or once you finish entering everything, then maybe you can flag it. Yes, ma'am. Correct.
Thank you, sir. Okay, before we wind up, certain announcements. Hope you guys learned quite a bit today, right? So now that we're concluding this session, we have to set out with certain goals, right? What next, right? Yes. So, what next? So, 3 homeworks we'll give you. One is building your search strategy, which we learned in the first session, and showing it to your guide, which has to be done within the next 2 weeks. Okay. Next is coming up with an outline for the review of literature and showing it to your guide. Like sir pointed out now, from broad relatable issues to the current present, what are the research problem related. So that making an outline of it within the next 1 month, and hopefully within the next 2 months you have to show your guide how you started working on it so that they can do the course correction early and you can write it. Our aim is that in the final year you should concentrate on like studying rather than, you know, last minute finishing your thesis and being behind that, right? So that is our intention. And the third homework would be, sir showed you how to make the master chart from Proforma, right? So then do that also and show to your guide. So in the next 2 months, your search strategy validation with your guide, review of literature, making an outline and starting writing it and show, right? And then master chart to show it to your guide. Make sense? This will, trust us, now it feels like we're giving you so much homework after a day workshop, but this will make your life easier in your final year, which is the intention, right? Okay. Before we leave, thank you very much for your patient listening. We would like to thank the moderators who stayed through the day. Veena Karant ma'am from Surgery Department. Shreya ma'am from Department of Anesthesiology. Jitin sir from Department of Surgery. Right, and Sanjay Kini sir, he just left from Department of Community Medicine. And would like to thank Anil sir, who's the senior advisor and made the whole workshop possible and gave us what are the topics, what would be this thing. So last time we conducted a half-day workshop and we got a lot of feedback that it was very small. So then sir and we like thought about it, and then we wanted to make sure that you guys get enough hands-on practice and it should be most useful, and sir made it possible to make it a full-day workshop. Thank you. 2 work before you go today. One is in your WhatsApp group, which is, if you guys are not in the WhatsApp group, please make sure that your friends can add you, or you can come to us and we'll add you. In the group description, a post test has been added. Okay, so you answer that post test and give this feedback. This feedback form is attached, linked to your e-certificate. So you'll get a certificate for attending today. When you go to this feedback form, in the full name, don't write doctor, just write your full name directly and make sure your email address is correct. Because when entering, if you write wrong email ID, it will go to the wrong this thing. Okay? So because later, please don't ask for the this thing. So name, don't write the doctor, and then email ID, make sure it is correct. Okay? And post this, please fill it. Okay? After you are done with this, you can leave. Thank you.